Welcome to another episode of Misfits Social Podcast. Paul, how you doing this morning?
Man, I'm doing great. Oh, thank you. Nice sunny morning out here in Texas, man. It's awesome.
The sun doesn't go too well with the Santa beard. We need to be more in the Arctic.
Thank you for that comment.
Yeah, on another episode where we were talking about offense, I wanted to make sure I started with you being offended. That way I could get that extra little spice coming in.
Thank you.
A little dopamine.
Nice of you.
Dropped into your system.
Yeah.
I can always depend on you.
Yeah. So for our guest today, Debbie, if Paul is a little bit spicy, you can blame me for calling him. He really likes when people compliment his beard in a Santa type way.
Fashion.
Noted.
Yeah. So if you could do that as many times as possible in this recording, that would be.
I'm a quick study, so I think we can do
fantastic.
Mm-hmm. Jingle bells.
Yeah, so it's good to have you, Debbie. Debbie is the Chief Operations Officer for my company, Tungco. She's been with us for a few years, so we want to take a little bit of time and let these guys get to know you. I've known you for several years, both as a customer, as a supplier, and now as a working relationship. So give us a little bit of your history in the world of tungsten and powder metallurgy.
Okay.
Powder metallurgy.
Power?
Awesome. Powder.
Yes.
Yeah.
Now my accent may have sounded
Kind of
more like
doesn't go together. Powder and metallurgy.
Power.
Yeah.
But as Debbie leads us in the chemistry, you will understand how powder and metallurgy, they go together.
Yeah.
You're going to love it.
Get ready. Buckle up.
It's going to be like potholes and asphalt. It's going to be fantastic.
Yeah.
I have questions.
You do? I might have answers. Maybe.
Welcome, Debbie.
Thank you. Thank you very much. So let's see a little bit about myself in my career. I've actually been in the tungsten industry for almost 30 years. Don't know if I really want to date myself. I actually started, when I was like 12. So yeah.
That's what I was thinking. Exactly.
I started as a process engineer, a chemical engineer. I worked at a company at that time that was known as Osram Slovenia. And then now they're known as Global Tungsten and Powders. And I started as a process engineer there in their chemical plant, went over into their powder production area as well. And over the course of the years, just kind of began to work my way up through some management, started in middle management, then was in what they would call the plant manager of the chemical and powders groups. Had global responsibilities for that. They had some operations in Europe as well as in Pennsylvania. That takes me to about 2017 or so, and then I was asked to move over into the sales world. So I ended up being the vice president of sales for the business unit of all their powders. Again, global sales responsibility, sales workforce throughout, and did that through about 2021, and then coming out of COVID, had the opportunity to come on board here at Tungco as the president of Lineage Metallurgical. Was very excited for that. Cliff and I had known each other maybe since about 2010 or so. And so John joined on in about 2021.
It's kind of a man's world, isn't it? Metallurgy? Come on.
So
I mean, isn't that
obviously not?
Hard?
Yeah,
obviously not.
No, it had to
it
be
was very
hard.
interesting, actually.
Yeah,
it's only slightly offensive, right, Debbie?
Well,
yeah.
You guys started with the beard, so go ahead.
I told you he was going to be spicy.
He's fighting back.
I just dropped the beard. Now he's like, oh, okay,
Yeah.
okay.
Hot tamale.
Yeah.
Misfits.
I would say actually when I started there, when I was going to school for chemical engineering, there weren't so many females, of course. So that had some positives, of course, So you think of some benefits from that perspective. But when I started work, there weren't so many. There was more females there than I envisioned. However, they just were not a lot in the manufacturing area, I would say. So a lot of the guys, it was new for them, for sure. Sometimes, at that point in time still, there were a lot of maybe like calendars and different things like that, and I honestly, I would always be like, look, I'm not one that's like, that's bothering me at all, because I know that's their work environment and I'm trying to come in and I don't want to come in and be like, oh, you must change everything because I'm a female. But I've definitely seen a lot of things for sure in the time in this industry.
Yeah. What's your superpower? I mean, what do you think kept you rising in the industry? And
I would say maybe my ability to execute, and I think also just maybe my empathy, maybe to use that kind of word. Like I am really one that I'm pretty good at making relationships with people. I like to hear what's the problem, see if I can come out a way to help them solve the problems. But I think that would be one of my superpowers.
So I would say, if I can just brag on Debbie for a second, having worked with her. Interestingly enough, when we first met Debbie, we were in Dallas.
We were.
Because it was for a golf tournament, and she was working for another company who was my customer at the time, and we were on the same golf team. So that was, being here in Dallas is kind of cool again to be shooting this. But, engineers are unique. They're unique thinkers, often very critical thinkers. And for me, when I met Debbie, I would have not put her in the category of being an engineer. And the reason why is because I feel like she can kind of come in and out of that mindset.
She kind of had a personality.
Well, I'm trying to soft sell it. I'm glad you said it.
Sorry, all engineers.
Yeah, sorry, engineers.
We're sorry.
That's not
To offend an entire segment of people in our world.
If you got hate mail, throw it at Paul.
Address it to Paul Cook.
But her word about the empathy, I think she does have. She actually has a pretty big personality, and her ability to listen to somebody else's thought and not over critique it, especially if it's all right. If you're thinking a thought just about a sales tactic or whatever, that's one thing. But she can come into an environment where an engineer would like speak into that and speak change into that, and she's not coming at it from well, I have the right idea. Even if she already believes that, you're not ever going to know that. I mean, you won't even know that after it's done. And you might be completely sold over to her side. And then you're like, oh man, that was her idea all along. But you're never going to know it until you're like miles down the road. So that's one of the things that I think when you asked what her superpower was, we talk about being disarming in conversation. She's very disarming.
So, like, are you taking credit for the changes she's made in the company? Is that what you're kind of trying to say?
Oh, no. I'm giving her all the credit.
Oh, okay.
Yeah. I may have thought it was my idea, but once it was done, I was like, no, that was Debbie.
Yeah.
That was Debbie all the way through.
Inception is what that is.
That's right.
Yeah. It was planted deep.
Yeah.
And you're like, this is my idea. It's like,
yes. She was precogging me on that. Yeah.
What I'm curious about, Debbie, is you said 12 years old. So I'm really curious what led you down the chemistry path or the metallurgical path at such a young age, 12, because you were saying it started around then. So tell us about that.
She's like 30 right now.
Yeah, thank you.
Yeah, so that was only just what,
turned 30.
Maybe 10 years ago?
Yeah.
I totally get it.
Actually, I would say I always seemed to have that interest in math and science. That all came very easy to me initially growing up. And when I was in high school, took my first science, like a high-level science class. I think it was actually biology or chemistry. And our guidance counselor actually took a few of us to an event in Pittsburgh. I grew up south of Pittsburgh, and we went to Carnegie Mellon University. And there was an event that was held by the Society of Women Engineers. Oh. And I got to see a lot of things like that. You know, what are women doing in engineering, different kinds of engineering. And I always had this knack for science and chemistry. Really, I was always interested in it. And one of my first jobs actually out of school there when I was a process engineer, I was actually dealing with cobalt, the metal cobalt, and actually the chemical side of it. But it was so intriguing to kind of see how you would like start with a black substance. You treat it, you do a process, and it was this gorgeous purple. And then you did another treatment and it turned orange. Mm. And at the end, you brought it back to a black material. And that just has, I guess that's the geek in me. I don't know. I just have that was always something that was really intriguing.
Fascinating.
It is cool.
And when you're talking about those colors, like if you look it up online, like it's super vibrant. So the purples, the blues, the yellows, the oranges. I mean, it's not like, you can't replicate it like on our clothes. Mm-hmm. Our clothes are like, a hue of that. But correct me if I'm wrong, Debbie, but aren't some of those metals used even in paint to
Yes.
to bring out the vibrancy?
Definitely the cobalt. Definitely they'll use the pigment in cobalt for glass. So sometimes if you see like the blue glass and things, that is going to have cobalt in it. And fun fact for you, I'm going to give you the nerd, the chemistry side. You know, when it's like that purplish color, it's like the +2 valence, and when it's orange, it's +3. So you actually are doing some transformations in it. You know, all that fun stuff. But
Love it. I think my brain just grew like 15%.
I pretty much glazed over for the whole conversation.
You were like the Grinch where his ears go up and then his
I just
hairline
grew a little
parts out.
gray matter, and I need all I can get. You know.
I concur.
So Debbie,
incredible.
unpack. Paul was like powder metallurgy. So just unpack a little bit when we talk about that. How are we getting the hard metals that we deal with from a powder form into something that is hard, workable, going on to steel, cutting aluminum? How's it go from powder to being the number one cutting metal or ceramic in the world?
So I would say there's several steps. There are several steps into making it into hard metal. You would typically start with a tungsten powder. You're going to carburize it with carbon. They're going to add some other metals depending on what the end is, their end application that they're going to be using. So
Is
you
this
might
a
add some
chemical
things
add
like
or a heat?
titanium, tantalum, niobium, some metals like that. They spray dry it. They make what they would call ready to press powder. Then the next step is kind of pressing. So they're going to either use like isostatic pressing, dry bag pressing. You're going to press it into the shape that you're looking to make. So if you want to make like a cutting tool or a drill bit, there's different molds that you're going to press. And there's obviously science into that because you deal with like the hardness of the materials. You need to understand things like that because here comes the buzzword. When the next step after you press it is you're going to sinter it in a sinter furnace. Typically temperatures over 2,000 degrees Celsius, somewhere in that range. But at sintering, you actually get some shrinkage. That's always the funny word in the carbide industry, of course.
We all look away.
Nobody likes Nobody likes shrinkage.
I didn't
No
know that.
shrinkage.
What was that?
So then, so there is, like I said, there's this pressing, then there's a sintering process. And that's what kind of takes it from the powder to the hard form, to hard shape. You then, depending on what you're looking to make, there's going to be grinding steps. There's going to be other post-processing things that happen.
So it's the heat that melds it all together then.
Correct.
From the powder.
From a powder.
And
Yeah, so just think about it like anything that you've done in the kitchen where you would have a mold for, like making Christmas cookies or your cakes or even your muffins.
It starts as a powder.
You're putting a powder in that mold. But they're pressing it. And Debbie, when you say isostatic, just unpack that a little bit. That's actually being pressed under pressure.
Yes.
It's not just like just putting a little pressure on it. It's like super duper high pressure. So when the part comes out, you can actually hold it in your hand.
it's going to be kind of green. They would call it green.
Yeah. So you could hold it, move it around, and
Probably
actually
brittle.
Yeah.
it can be. But
This is before heat.
this
Correct.
is before heat.
Okay.
So like we have one customer that does what's called preforms. And in those preformed shape, it's actually machinable.
Oh wow.
Yeah, so they'll machine it
Preheat.
preheat.
Wow.
So it gets on the under that isostatic press. If you've ever seen a video of them making rebar, they'll take be like a molten round stock, and it's running through this roller. Well, that roller is tungsten carbide, or it's probably not. Is it tungsten carbide or heavy alloy?
It'd probably be heavy alloy.
Yeah. So, and that shape that you see on the rebar is in that form.
All the little grooves
Yeah.
on
So
it.
when that round stock runs through that mold, it's putting those ridges on it. So whenever they're making those molds, though, I mean, you're talking about some of them are probably as much as what, Debbie, 25 or 30 pounds, the big dies.
Yes.
And so when they're preforming that, they'll shape that out a lot and mill it out before they actually sinter it. Yeah. Yeah, because the workload on the tooling to sinter or on the tooling after it's sintered is very, very intensive. A lot of companies, if they mill it down before they sinter it, they can actually then reuse that powder. If it's sintered and then they have to mill it down, now you've got scrap.
Yeah.
And that's where when we talk about sludge a little bit, that's where that sludge comes from. So when it goes when it goes under sintering, there's also, Debbie, correct me if I'm wrong, there's sintering furnaces that are also under high pressure, right?
Yes.
So explain that for us just a
They're
little
doing
bit.
both at the same time. In other words, heat and pressure.
Yes.
Because that product just needs it all done at once, or
Explain a
whatever
little
you're
bit
making.
of
Yeah,
why it needs to be under pressure.
Uh-oh.
Isn't it because like whenever so
Paul
you've
can
got
answer.
nickel and cobalt mixed in the powder,
yeah,
right?
I'll help
that's
you
fair.
anytime.
Yes,
Yeah.
yeah.
And so-
you
Put
have
it on
the
you.
different.
Yeah, and so
Yeah.
when it's being sintered, if it's just under heat, there's
Might
no
not
pressure on it to make anything
form.
happen. So when it's sintering, your cobalt and your nickel is liquefying inside the part. So when it's under pressure, it's correct me if I'm
That's
wrong,
right.
Debbie, but isn't it pressuring it to find the voids
That's correct.
inside so that you don't have any voids? I mean, when you
them.
get it out and you look at it, you're like it's a centered part. But if you have a part failure,
Yeah.
go ahead.
Yeah, no, it is definitely allowing that. That's helping to form more of making a more uniform microstructure, making a more uniform mix, I guess I would say, and because definitely things like the cobalt, the nickel, they all have different properties clearly. So you do need that pressure to help that really maintain that shape that you're looking for in the end, as well as the temperature. And if you don't, that's definitely something that they will look for once it's done pressuring. They are going to try to look at, they'll maybe take a cut and do like a SEM, or they'll do testing on it. They'll be looking at what they would call they want to see how the grains all grew together during that sintering process. Make sure they are not any like holes, deformities, pits, things like that.
Because it will fracture.
Because then it will
basically.
fracture. Exactly. Yes.
Yeah, so when they cut it under a microscope, we always make fun of Paul about roads because when we had the mayor from Madisonville on the pod, they got to talking about roads, and we actually had to be like, okay, we've talked enough about roads and potholes. We got to get on
And the
something a little
budgets.
bit. And budgets, yes.
Yeah.
But
Gravel
to
content.
go risky here and talk about roads for a second,
Oh no.
yeah.
What have you done?
Whenever you see like the edge of an asphalt road, like where all the gravel is kind of laying on top of each other, and then they've had the tar go into it. If you look at tungsten under a microscope, if you cut a solid piece on and then look at the microscope, that's what it looks like, is a bunch of rocks laid together, and the cobalt and nickel is doing like what the tar would do to a road,
Okay.
Yes.
and just filling in the void. So you got
Right.
so then you got a solid surface. And if that doesn't get filled right, then you got a weak spot, and then you'd have a pothole in your tungsten carbide. So
Or like maybe a ribbon that runs through it or
yeah,
something
exactly.
like that.
Yeah.
Man, we have tied it all together.
Yeah,
right
I
there. That is
Don-
fascinating.
circle
I
moment,
Donald
huh?
Trump that conversation. I was weaving and
That's
wobbling.
incredible.
So when they grind the roads there in Madisonville,
Oh,
Yes.
Lord, Debbie. Okay,
Well,
we're
they
gonna-
do use a tungsten part when they
See,
grind the roads.
I knew there would be an
It
application.
all comes back to roads.
So, Debbie, chemistry, the science, wow, what's kept you going all these years in this industry? You know, just that, would you say it's that wonder of that you said math and science, that's what got you at 12. What would you say keeps you going today?
Well, the check on Friday.
Besides having to pay the bills,
It has definitely been a nice way for my family to live. Yeah, definitely from that perspective. But I think for me, it's usually different. So while you are producing the same products a lot of times, but there's always, for me, I always feel like my week, it's not the same daily grind. You don't know what you're gonna come into at work typically on a daily basis. There's going to be different challenges come up, and that's been something for me that has always been really intriguing and enjoyable, I would say, and kept me going. I think as well, learning a little bit more relationships. I would say learning a little bit more about the industry, about the players in the industry, and how important it is to have relationships with some of those folks. You kind of get it really becomes almost like a family in a way.
And it's an international
Yes.
business, which is really cool.
Yes.
You get to know a lot of people around the world.
And I've been able to see places in the world that I would probably have never imagined that I would go to if I wouldn't have been in this industry. So I
How
had
big
that
of a
opportunity.
product is tungsten in the metal world? I mean, is it in everything and everywhere? Like what percentage of the business is tungsten in the metal world? Is that
I don't know if I know that stat of what position tungsten is in the entire metals world, but I would say that tungsten is in almost every aspect of your daily life. From some of the lights that we have here, not just like your incandescent bulbs, not from your, if you think of those lightings, but high lighting from movie projectors, film industries, medical applications. If you get a CT scan, a lot of those targets have tungsten in them. Of course, road construction.
road grinders?
Right? Road
We
construction.
can't leave it.
Road grinding.
Road grinding.
I would also say electronics, agriculture, aerospace,
Everywhere.
phones.
Yeah.
So it's really,
What about a pen?
oh,
Ballpoint pen?
absolutely. How could I forget? That was actually one of a very neat thing to be able to
Yeah,
see. I would have
Claude
never
would be
known
very
that.
disappointed that you didn't
yes.
lead with that.
The little ballpoint.
Claude Lanners, if you're listening to this, we
Yeah.
want you on the
Yeah.
pod. We want
Yes.
you on the pod in your red pants.
Yes.
The ballpoint pen tips. Rings, jewelry, right? So there's the tungsten carbide rings are big.
So
now.
Debbie, you said the one of the first places you worked was at Osram, right?
Yes.
So if you've ever went to buy like the long incandescent bulbs, if you think back, Osram, Sylvania, like if you were at Lowe's or whatever, or today you still go, you see Sylvania Lighting. That was the company that owned
Correct.
what is now Global Tungsten Powders. And the reason why is because of the amount of tungsten that was in the lighting industry at one point.
Yeah.
So that company, you guys do scrap. You provide the scrap to a company like this that she used to work for.
Correct. Yeah.
And they turn it back into powder.
Correct. Yeah.
And
Powder
what percentage of the
products.
market is repurposed tungsten, and what percentage of the market is raw material? You guys don't have answers for me. I'm just really disappointed.
Well, I think that sometimes is a little bit of it's going to be dependent on the smelter, depending on the company. And there's also going to be cycles of times when it's going to be greater than 50%. And there's going to be times when it's going to be less than 50%. There's all sorts of different variables and factors that go into the decisions of some of the smelting companies when it comes to figuring out how much of the mix they're going to use.
Like what they're going to use, if it's raw or if it's repurposed.
Correct. If it's good. Yes, that's correct.
Yeah. But it's pretty common knowledge that it's about 100,000 tons a year as the global tungsten
Yes.
demand.
For raw or scrap.
Just
Period.
say 100,000 tons. Period is
What
what's
would that be in
consumed.
like a train? I mean, like it's hard for me to wrap my brain around 100,000.
So you can get 60 tons, I believe, in a train car. A tractor trailer is 20 tons.
A tractor trailer would be about 20 tons. Yeah.
Yeah. So it's a few.
That's
but
much.
if you were talking stainless steel, you'd be talking, I would say, millions of tons, not 100,000. It would be.
Right,
we're not
because tungsten
stainless,
is
but
more of an additive, right? It's more of a. I think for wear and tension and.
yeah. So like where stainless is actually used, or let's say titanium. So if you ever fly in a plane and you look down and you see the little top of a metal runner where your seat ties in, all right, that is a one solid piece of titanium running the length of that aircraft that they tie those seats into. And that one piece that's that long, you could pick it up and hold it yourself. So it's like functional in terms of it's used in that aircraft. There's not a lot of outside of, Debbie mentioned the X-ray machines. So it's actually, it's used in that piece of equipment because they're replacing lead shielding with tungsten shielding. So that's what keeps people safe from the radiation. But everywhere else, it's used in actually making a part. It's not like something. So if we say, hey, we use tungsten carbide to make automotive engines, it's not in the engine.
Yeah.
It's what's turning the whole, like if you look at an engine block, the way you get that engine block, you don't get that without tungsten carbide.
Okay.
Like it turns the entire engine. So where the valves are, where the pistons go, where the cam sits, all of that is turned by a tungsten carbide part.
And it's much more expensive.
Correct. Yeah.
Tungsten.
It
And
is.
turning is the technical term for what, a layperson would call carving, shaving, cutting it out, right?
Yeah, like so for a CNC lathe
Yeah.
or end mill, any type of machine shop that you go to. I mean, every town in America has multiple machine shops. So if you go in a machine shop, I don't care if it's in a guy's garage, he's got tungsten carbide in there. Now he might only have 10 pieces, but he's doing that to do his metalworking.
It's hard enough and durable enough to cut into another hard and durable metal because it's
Correct.
Yes.
harder and
That's
more
right.
durable.
That's right.
Yeah.
Right.
Yeah.
You were mentioning some place like Portugal, but most raw materials harvested in China. No.
Well, so I'm going to let Debbie talk about that.
And then what does it look like when it comes out of the ground? I imagine it's mixed with other things or something. I mean, it's not like you go dig out a powder of tungsten, right?
Correct.
So typically, I would say actually the amount of tungsten in the ground is, when it's raw, it might be 0.5%. 1% would be wow. That would be really, you'd be in a really nice vein.
So you're
of
harvesting
tungsten.
a lot of material to just get this little bit out.
There's different types of concentrate, or I guess that at that point it would still be called ore. So there's going to be something that's known as scheelite, and that's going to be a calcium tungstate, so that's going to have more calcium. There's a ore known as ferberite. That's like an iron base. That's an iron tungsten. There's hubnerite. That's a manganese tungsten. And there is just general wolframite that's kind of got a little bit of the different impurities, like a mixture almost.
So in the wild, tungsten tends to be found with something else.
Correct.
Is that what? Yeah.
So the mining process, they
So
would
then the
harvest
mining
all of that
yes,
material
correct.
and use it and divide it up.
Yes, yeah. And that's, sometimes there's going to be byproducts from the mining industry that then will also give value to that mine. Some of them might find bismuth, the gypsum, different things like that they might be able to do. But when you go from less than 1% tungsten, and standardly by the time they do concentrate that up, so they're doing all this different separation processes, flotations, mechanical separations and things, you're looking at probably bringing that up to about a 60% tungsten.
So that powder.
So if you ever watch the TV show Gold Rush, where they're harvesting the gold in Alaska and some of those far out regions, where what it looks like they're doing is washing it, but in this world, in the mining world, they would say they're concentrating that up because they're getting rid of all the stuff that they don't want.
Correct.
And so if you looked at a big ute where it's just this huge load of dirt and rock, I mean, think about looking at that. That might be a 20-ton load, and there's 1% of tungsten in that 20 ton.
Yeah.
One of the best illustrations is at where she used to work, Global Tungsten Powder in their foyer. They have, it's probably about a 5 or 8 gallon cylinder.
Yes.
And it has all these rocks in it that would have come out of the ground. And then right next to it, they have a little plastic container
little Petri dish.
that's like the thickness of a quarter and the diameter of a quarter, and it's got powder in it. And the illustration is that's how much tungsten powder came out of all those rocks in that
That's
container.
why it's so expensive. Yeah. So what's I'm pardon my ignorance, and I'm not a geological expert, but rock is made under pressure, granite, and what's the difference between that and coal is biodegraded plant products and animal products and stuff. So what is the difference between that, that pressure and what makes stone and what makes metal? Is that a weird question?
Yes.
Or is this just my brain that's doing
It
this?
is.
Yes,
True.
it is a weird question.
It is weird as I don't know if I have an answer
Yeah.
for you on
guys
what
don't have
makes those
answers.
different.
I'm
I
disappointed.
know. Man, I forgot to take my pills this morning.
I know.
My knowledge pill.
I'll
this
Google
morning.
that.
You didn't get in founder mode.
No,
You didn't.
I didn't.
But to follow up on the theme of the idea, you were saying, so like once we get tungsten to a pure state, it's still, let's say we have a cup of it, it's still only 60% tungsten. Is that what I'm hearing? That one of those statements you made just a moment ago.
Correct. So there's still going to be some impurities. Like I mentioned, maybe there might be some manganese, there might be iron, there might be calcium. Depending on where it is, there might be a little bit of thorium and uranium. So different parts of the Earth, I guess, or the globe have different these natural minerals that are there as part of it.
I know I've picked up some powder in a container, and it's so heavy, right?
Yes,
Is it one of the
dense.
heaviest metals? I assume it's just so heavy. It's like shockingly heavy.
Pure tungsten?
Yeah.
I think the only thing that's heavier is gold, right?
Yes.
Yeah, gold is the only thing that's heavier. Yeah. Yeah, so it's, it is an expensive product, but when you think about the efforts that go into getting it out of the ground, and then, Paul, you were referring to China a little bit ago, and there's mines right now in Portugal. There's some mines in Spain.
Correct.
We actually have reserves in the United States, and Canada. But unfortunately, those mines are no longer operating. One of the challenges, as we've mentioned, with how expensive it is to get it out of the ground, no matter where you're at in the position of Trump and his chaotic rollout of the tariffs, or whether you agree with it or not, one of the things that I think the average American doesn't understand is that tungsten is a critical raw material, and the reason why it's critical is because it's critical to every aspect of life. So just the list that she was mentioning a while ago, you've touched, whether it's you drank out of an aluminum can today. If you did that the bottom part of that can was shaped with the tungsten dye. I mean, there's so much that we do
Car you
in
drove
life.
today this
Yeah.
morning.
And I didn't even mention defense.
Yeah.
Right?
Right. Yeah.
Yeah, so about 10% of the overall global usage of tungsten goes into defense. So if it's armor piercing or does any major damage, it's tungsten that's doing it. So the concern then is, one of the reasons why these mines are not sustainable is because there had been so much coming out of China that when a mine would get up to the place where it was profitable and they could sell it because the price had worked its way up, the Chinese would come in and just drop the price. And so there was no restriction. So, I mean, again, a company has to do what it has to do to survive. So you can say, well, a company should have only bought American. Well, they have to make a decision to stay in business or not stay in business. So we're not going to debate that on this pod. But what people do then is they go for the material that they can afford, which is Chinese. The price starts to soften, and then the price gets below what these Western mines can even produce it for. So they run out of cash.
What was that tonnage you said was the usage in a year?
100,000 tons. Yes,
And
sir.
so like a mine, like one of these Western mines, would they produce?
About maybe 5,000, or in the range maybe 5,000 or so
it's
ton
like
a year.
minuscule. Wow.
Yeah.
I mean, a big mine would be like 10,000
Yes.
tons
A year.
a year.
Yeah.
That'd be a big mine.
That's just a drop in the bucket.
I mean, the one
10%
in
of the-
Portugal is probably doing what, 1,500 tons to 2,000?
Probably around that 2,000
Maybe.
range.
Wow.
Yeah.
So I mean, it's and
Small
so
percentage of
so what we were talking about, if we are only reliant on scrap, the issue with that is right now the global perspective is that there's about 30% is the recycling rate that we're at. So you've got 100,000 tons of demand, and globally we're speculating that there's about 30,000 tons being recycled.
So some of the scrap just isn't being found. It's just being wasted.
Well, some of it's not recyclable. So if
Yeah.
it goes boom,
It's,
all the defense stuff.
yeah, you're not getting that back. Ballpoint pens, you're not recycling that.
see.
So there's a lot of stuff that is not easily retrievable to get it back.
So most
into
of it
the
you're
supply
getting
chain.
from manufacturing.
Correct. Yeah. I think Debbie, what would you say from like just the tooling world? What's the rate on that? It's probably a little bit higher, right?
Yes, I think the tooling world recycle rate is, I would say, probably maybe 40 to 50%. I think that one's definitely pretty high. Like Cliff kind of said, it's a little bit more obtainable, a little bit easier to be able to recycle some of that.
So what is it worth a ton? So you've got that demand. What is that number financially? Yeah. What's it worth a ton, or how do you price it?
Trade secret alert.
Yeah, trade secret alert. Well, I mean, so let's talk just silver and gold for a minute. Like I can pull up my Wall Street Journal app. Wall Street Journal, if you're listening, will take support. I can pull it up and pull up what the value of gold is like right now. You can't do that on tungsten. There's not a quoted in like a Wall Street Journal, Financial Times kind of deal. There is a quotation on what's called APT.
Ammonium paratungstate. It's like one of the precursor for the first intermediates that you do produce in making pure tungsten and tungsten carbide.
But it's not a published price. So it's an indexed price, but you have to pay for a membership to get that price. I'm not going to say what those groups are called, but most people in our industry believe that quotation today is complete bullshit.
Fair.
Is that fair?
Oh yeah, I would
like
say fair.
overinflated or
Well, it's just
you
can't depend upon it because they can't quote a contracted price.
Yeah, supply and
There's
demand
criteria.
and all of the things.
Yeah, so the majority of all the quotation is coming from only like 10% of all the business in the world, because all the bigs have quotes or have contracts, so they can't quote that price. So then they go to some person who's doing like one truckload, and so that can move the global supposed value off of one truckload. So that just seems kind of not good. So when you're saying, hey, what is the value? It really just comes back to Econ 101, supply and demand is what moves the price.
And you measure it by the ton, or you measure it by the ounce, or how do you measure the saleable price of tungsten?
A lot of time it might be by powder is going to be maybe by the kilo, by the kilogram, or by the pound. I think once you start to get to the parts and things, it might be by the piece. It might be like price per piece is X, whatever it will be.
Yeah. So coming out of the ground, what are they? Is it MTU?
Metric tungsten unit.
Yeah. So that's kind of coming out.
Not to be
That's
confused with an
interesting,
STU, which is a short tungsten unit. So
Wow. 30
you
years
don't learn
in the
that in
industry.
college. That's
I'm not
definitely
gonna learn
some
that
things
in
that you
this-
have
in
to
this
learn on the
podcast.
job.
Yeah.
Well, as a curiosity, gold and silver traded openly have, I'm not sure what the language is, but that defined market
Commodities.
price. From your opinion, is there ever any reason that would be a good thing, or why is it not? I don't know anything about that, but I find that interesting.
People trade futures like with gas and
Sure.
and
Yeah.
But my question is, tungsten or some other metals like that, do you ever want that to be defined like that, or that doesn't work well for your business model? I'm curious as to, yeah.
Debbie, you want to take that?
No, I don't think I'll let you. Other than I would say for me, I think I'd like to see it sometimes just stable. I think stability is, I think a lot of the consumers and producers both probably would just like for it to be a little bit of a stable period, pricing wise.
that's never happened though, has it?
Understood. What keeps it from being like, obviously gold and silver, they're very precious metals, but why would tungsten not have that standardization market price wise or universally recognized? And I'm asking that as just a complete novice to that whole industry. Why do you think that's not, or some metals don't have that, or?
Yeah, I mean, I don't know at what point we decided we were going to do that. I mean, clearly at one point we had the gold standard
Right.
So there was a lot of regulation around gold. But if we say like nickel, you can do nickel futures. You can, you can short it. You can, you can hedge it. You can take a position on it. I don't know if that comes down to volume. But at the end of the day, I think no one has been willing besides Fania.
Yeah, that's fair.
So Fania was a group that was inside China, and that's what they were trying to do. So they were trying
standardize that.
They were trying to standardize it, and they got to the place where what they were so to do that, you have the only way you can. Now I'm going to speak way out of turn, because my knowledge about this is about as thick as that little wafer I was talking about a while ago of tungsten. I mean, it's real, uno poquito, but
exponentially more than mine.
So it has to be backed. So if let's say the four of us wanted to do that, we can't sell those futures or do different things like that without a backing, because if it gets called, then you have to be able to either produce. You have to be able to produce that. So Fania, what they did was they were a group that got together, and they had at one point they had 2 years worth, right?
Very close to it. Yeah.
They had 2 years
stockpiled supply.
Yes.
Yeah, they had 2 years worth.
Okay.
So that would mean they were sitting on 200,000 tons of inventory. I mean, it's physical. You can put your hands on it. You can touch it. So outside of Warren Buffett, there's not a lot of people who have the pockets to do that. And then it's not been done. I mean, it was tried there, and they ended up defunct. So it went completely bust. So it would take somebody like a Warren Buffett with that kind of wealth, and then they have to be willing to say, okay, I want to take that risk. And the challenge for somebody like Warren Buffett is they're going to say, well, I need to know that industry. And you listen to her spit stuff out. Well, she's been in this industry for 30 years, since she was 12, right?
Start glazing over, yeah.
So it's not an easy thing to know. In fact, if you want to be a tungsten metallurgist, you have to go to metallurgy school first, get a degree in metallurgy, and then you have to go intern somewhere else for 2 to 4 years to learn how tungsten works, because it's just not big enough.
That's it's fascinating, and I think the answer to that is really even more fascinating than I realized. I think that's incredible. I'd like to ask a question, just turning it back personal to you, Debbie, because the whole tungsten thing I find incredibly interesting. But if you'd be candid with us, like your years in this industry, what would you find to be the biggest challenge for you personally in your leadership, your career? What mountain have you climbed, so to speak, and that you feel a great accomplishment and a sense of accomplishment in it? What would that challenge be if you singled it down to one thing for you?
Well,
working for me.
Did we say this is an hour-long podcast, or how long do we have?
How much time do you have?
No, I'm kidding. I think I'd say, how do I want to word this exactly? But I think sometimes a challenge for me has been maybe being younger with some of the folks that had a lot more season, a lot more seniority and stuff, and getting them to sometimes be willing to accept some of the ideas or thoughts that you might have, being able to let them see there might be another way around to solve a problem or to handle a situation. I think that's always been a challenge, I think, as well. Just being a female in that man's world has definitely been, there's been even it's little things like when you go somewhere and they may not have even had like a ladies restroom, or just things along those lines. One time I visited China, they had said it was actually the first time they had a female there to have some meetings at like my level, to have some meetings and some discussions. So just seeing a lot of those sort of things or coming in contact with those over the years has definitely, I would say, been one of those challenges.
I think that's incredible.
But it's also kind of neat. I've always been like, hey, if I wake up and the sun is shining and I've got my health, I've got my family, and I can pretty much take on, I would say, whatever is going to bring my way. But
bravo.
What has Debbie brought to the table for Tungco?
Oh, where do I start? Her experience in terms of the the engineering, chemically side, is a whole nother way of thinking about things. So for us to be able to move in any direction where we're really helping our customers, and that's, for me, that's where you make a big difference, is being helping your customers solve problems. Yes. Not just saying, hey, I have a widget and I can sell that to you, because there's somebody else who's got the same widget. So if we're talking about tungsten carbide scrap, my competitor's got the exact same thing that I have. So having a high caliber team member like Debbie, she can come in and help us be problem solvers for our customers. So if our customer comes to us with something, before, I might not have a full understanding of what their challenge is. Like, so she's probably said some things that you guys are listening to and you're like, I have no idea what she's talking about. So it'd be the same way when we would go talk to a customer. She helps unpack that and be like, hey, maybe this is the roadblock that's being faced. So then we can try that internal. Mm-hmm. So we can figure out, can we problem solve that? Can we find an end way, in run around? Maybe they're having a contamination problem and they're using some terminology that we don't even know anything about. So like the halogens example.
Yes.
That gets talked about in the industry, and the customer can tell us, hey, we're having a halogen problem. Well, when I think of halogen, I'm thinking of the only thing I can relate to a halogen is a halogen light. Yeah, and I don't even know what that is. I just seen it on the package, So I'm like, well, we don't have light bulbs in there. I mean, it's like there's no way to solve that for us, because we go to AI or something else to try to figure it out. But she not only brings the just the knowledge of it, she's got the experience of where that roadblock was there, so she can really help us navigate.
Having been in sales, the contacts too is like kind of like you bring this book of relationships with you, also.
Yeah. I mean, one of the main things that she brought to our organization is her live-in coworker.
Yeah. You're correct. I think I now know I'm maybe not the favorite West within the Tungco Corporation.
So what's that story?
My husband Kevin also did work at the same place I worked at. He was a production supervisor for them, and he worked there for about 25 years and was able to take an early retirement. And we seemed to think that would work out well. I was traveling a fair amount. We had a young daughter.
He worked there until Debbie fired him.
Yes, that might be true.
Kevin, we're going to have to let you go.
We'll pay for therapy.
Yes. So he was going to do the early retirement. And because my daughter was younger, like I said, I was traveling a lot. And like a year or so into it, he was like, not for me. That, yeah. This isn't going to work. So we did this other harebrained idea where he went and we bought a bar. So we actually also own a bar in Towanda, Pennsylvania there. And then, when we, he knew a little bit, in working at Tungco and everybody understanding a little bit about some of his background and such. And then when we decided and agreed that I was going to come and relocate to Madisonville. You
got a twofer. He went to work.
And saw the benefit that he had.
Basically, we needed a director of operations at the time, and Kevin had quite a bit of experience working in a plant. And that wasn't the original plan. The original plan was that Debbie would come to work for us, and she would work remotely from where she was at in Pennsylvania. Mm-hmm. And then a few things changed, and it just worked out. So she's, just for the record, he is not the favorite West. She is the favorite West.
Okay. I don't know. We should do a poll with the employees.
Survey.
So some of the, what we call the young guns, they like him, but I think that's because I think he has to buy their beverages to get that kind of favor. Debbie doesn't have to buy anything.
No, I don't. That is fair.
Debbie just has favor. Kevin has paid for favor.
Yeah. So whatever it takes.
Whatever it takes. So, Debbie, you mentioned your daughter just real quick. Where is what's she up to these days?
So Catherine is in her second year at West Virginia University in Morgantown, West Virginia. She's studying communication sciences and disorders, and she's got the inspiration. I guess she'd like to become a speech language pathologist. That's kind of where she'd like to go.
Nice.
That's kind of what she's up to. She's just enjoying college life and all that comes around it. Maybe a little bit stressed right now as we're getting close to the end of the semester and finals and stuff. But that's where she's at.
So how cool is it that she's at your alma mater?
Yes, I didn't even. That's obviously means a heck of a lot to me. I never pushed it though. When she was growing up, being in Pennsylvania, we actually were closer to State College, so to Penn State. So I never really even pushed West Virginia, even though Country Roads is literally my favorite song. Anytime it comes on, I'm like, hey, everybody,
Country Road.
we got to sing that. But so when it started coming time to start looking at colleges, I really never pushed her. And she started looking at a few in Pennsylvania. And then she actually wanted to look at the University of Pittsburgh. And I was like, oh, because that is like the rivalry. Like they would call it the backyard brawl, West Virginia University and Pitt. And I was like, oh. But we were planning it out. And she goes, but I actually would also like to check out West Virginia. And I was like, cha-ching, okay. So we...
Is it atmosphere and the campus that kind of brought her? Yeah.
Yes. Pitt is an amazing university, so definitely no diss on Pitt whatsoever. But I think as a mom of a young girl, there's something a little bit more for me, a little bit stable, secure. I feel like in the hills of West Virginia than, if you will, in the city of Pittsburgh. But WVU has about 25, I think right around 25,000 students or so, maybe a little bit more. Has a few campuses and it has lots of hills, definitely. So they always would joke that you wouldn't necessarily get like the freshman 15 at WVU because you were always walking up the hill to the different classes and everything. So,
And Morgantown it's
yes,
it's a pretty small town, right? It's not.
Yes, I think the student population is probably half or more of the town itself.
Yeah, it probably doubles the town when it's in session. Well, it's been good to have you on. We like to close out with tell us somebody that is a misfit for you. It could be somebody in the industry. It could be somebody dead or alive. Somebody don't know, just that gave you inspiration throughout your life and didn't do things that were just common.
So I would say, somebody maybe not necessarily in the industry. A fun fact, maybe people don't know that at one point I really wanted to be an astronaut. I used to joke and say I was going to be the first dancer in space. And so I was, of the generation there of the Challenger stuff. So I might say Sally Ride actually might be a misfit. She first U.S. female in space, not the first female in space, but she was always the first U.S. female in space. And then even after that, like she just was a big proponent into STEM and for women, young girls,
inspiring them. So I think that might be one.
Awesome.
Great one.
Well, my one for this one's going to be Debbie West.
Yeah,
the lady
mine too.
who came in and turned the tungsten engineering industry on its head. So Debbie, thank you for being a part of the Tungco team. It means a lot to me to get to work with you every day. And thank you for what you do for the tungsten industry. And thanks for being on the Misfit Social Podcast.
Great job.
Thank you all very much. It was fun.
All right.
Thank
It's
you,
been
Debbie.
another episode of the Misfit Social Podcast. Have a good day. Let's go.